Thanks for joining us here. It's going to be a fun time, I think. Literally came in the room, these guys showed up, and then next thing you know, they're building an app and doing some fun stuff, and they apparently got things to work. So I'm not even going to bother doing that much of an introduction, but in the blue, we have Mr. Mark Russinovich, CTO of Azure. Woo! Joining him on stage for some lively Q&A, you must remain in your separate corners, please, will be Mr. Corey Sanders.
I'm going to trump you.
From Azure Compute, in the red.
I'm feeling uncomfortable.
I'm very uncomfortable.
Now, this format that we've decided to go with, we'll be able to take questions from the audience and also from other means. But we want to start off first with some trends and everything else. And so when it comes time for doing some questions, you can use the who is that guy?
All right.
Someone let him in here. When it comes time for some questions, you can go ahead and use the hashtag.
He's been lost for many years, I think.
You can use the hashtag Corey and Mark.
For asking questions, yes.
For asking
hashtag
questions.
Corey and Mark, yes. Oh, hi. Surprise guest.
Good to see you.
Thank you. Yeah, you're the adult.
Yes.
So now we have 3 people that can answer questions. So let's cheer for, I guess, Jeffrey.
Jeffrey.
All right.
Ladies and gentlemen, Jeffrey Snover.
Okay,
All right.
friends.
Well, first trend, PowerShell. No, okay, so how many people have heard of containers? See, raise a hand.
What?
Anybody not heard of containers? One person.
No one wants to admit it.
So
Jeffrey, raise your hand.
let me just start for those of you that maybe have heard the term but are not familiar deeply with what exactly containers are and why they're such the hot rage in development these days. Container technology really began in the mid-2000s, around 2005, 2006. It was really pioneered actually by Google, who started to develop container technology on top of Linux, and as we know it today. And the idea behind it is you want to take a piece of code and you want to run it in a resource-isolated way, and you also want to have it carry its dependencies with it. Those two things give you reliable execution of the code on different systems, because as long as it's got its dependencies with it and it's got an isolated view of its dependencies, other code on the same server can't interfere with it by modifying those dependencies or breaking them. And other code on the same server can't interfere with its resource consumption because that resource consumption is protected by the operating system. The containers started to show up in more general ways outside of Google about 4 or 5 years ago. A company called Docker really kind of democratized them by defining a packaging format for them and an API to describe the constraints on how those dependencies were specified, as well as the resource governance around the container. Developers started to use it and found the container extremely valuable in their kind of inner loop F5 debugging development, where they could just create a container and spin it up extremely quickly, test it, shut it down. Once they got it working, push it up to a production system, and it would work reliably. This turnaround time went from minutes for a virtual machine to down to seconds for a container, and you effectively get the same kinds of isolation with respect to the application. And so this is why they started to just take off, and people started to really use them, and Docker became a kind of household name around the technical community. Fast forward to today, and now containers have become effectively the zip file for development, for packages of code. And you see us at Microsoft embracing containers in all sorts of ways. Every one of our compute platforms, from our batch service to Logic App, or so Azure Functions to Azure Web Apps, all take container images as a way for developers to supply code. And going forward, you will probably see that become, in many services that are new, the only way that developers will be able to supply code is as a container image. Container repositories are places where people share images, and so there's a huge ecosystem around that. But underneath containers, when you have a container, what you're doing is developing an application, and you want to develop an application that consists of multiple components. And this is where microservices enter the picture. Microservices and containers have become somewhat synonymous, yet they're different concepts altogether. Again, containers is just a way to package something up. Microservices is a way to take your application and decompose it into discrete parts with well-defined interfaces. And microservices are useful in complex apps because the complexity is broken down, and you can have individual teams work on the different pieces independently of the other teams. And because the code is decomposed, also, it can scale independently of the other pieces of the application. And for example, auto-scaling. And so the load doesn't just scale everything up together. It can just scale the tier that is getting the load. But the two go hand in hand because a great way to package up your microservices is as a container. And so what you're seeing today is the rise of container orchestrators like Kubernetes, Docker Mesos, Docker Swarm, Mesos DCOS, and even our own service fabric. People describe their applications as microservices, they package them as containers, and then the orchestrator goes and figures out how to place those individual microservice instances across servers or virtual machines. And so that is really where we are today, fundamentally as the mainstream way to develop cloud-native applications. But the trend here that we're talking about is serverless, which is the next step in this evolution of application development.
Hey, Mark, before you go on to serverless, do you mind if I riff on this a little bit?
Sure.
So as the lead architect for Windows Server, I was sitting there in the middle of our 3-year development cycle. I was sitting there in the middle of my 3-year development cycle, and the way we did this was we'd like plan for a year, development for a year, and then test and stabilize for a year before we shipped it. And I was sitting there saying, wait a second, why is it that I have to stabilize and test compatibility for a year? And even then when I do that, I always break existing applications, and yet Mark's over here in Azure, and they're releasing like every day or multiple times a day. And like, how can that possibly be true? Like, how do I square those two views of the world? And so I started doing some deep thinking about this, and what I realized was all about environmental coupling. Okay, environmental coupling. And what that means is that as an operating system, when I deliver services to you, often I'm delivering them as DLLs. These DLLs exist in your process space, in your address space. And so the environmental coupling is very, very tight, right? We're both working against the same address space. So any mistake I make or any mistake you make, the possibilities for interaction are very high and breakage. So too, even if we're just in separate processes, but we're on the same system, right? I update a DLL that you depend upon, it changes, and then I break you. Okay? So it's this environmental coupling that requires this incredibly high application compatibility. But with microservices, what it means is that I'm no longer talking to a service provided to me via a DLL call. I'm talking to it via a protocol, a network protocol. And what that means is my environment is completely decoupled from their environment. And this is the heart of the future. This is why you can be successful and move fast. And it's something you should, as architects and developers and decision makers, you should understand. And by the way, this is all possible because of a revolution in networking, right? The revolution of networking means we've got so fast, such high bandwidth, such low latency. By the way, never buy a server without an RDMA NIC. Write that down. Never buy a server that doesn't have an RDMA NIC. Because that's some of the stuff that gives us very low latency. Now what that means is, now all of a sudden calling a process across the wire is pretty darn close to calling it as a DLL. Not all the same, but good enough. And what that means is, now as my service talks to your service, one, your service can scale. Okay? So if it turns out you need to go from a small implementation to a large implementation, if it's on the same machine, we have to go to a bigger machine. That affects both of us. But as a microservice, that can scale out, and it's, it's opaque to me. Additionally, you can have whatever version of DLLs you want, whichever version of the operating system you want. You can upgrade the operating system. You can convert it to a different operating system. As long as you satisfy that protocol contract, you can go at your pace, I can go at mine. And this is the heart of the, again, of the future. And this is what containers do so well, is they say, well, here's my component, and I'm going to take responsibility for all my dependencies. I'm not going to put it on a system and hope that some IT operator will get it right and keep it right. I, as a developer, take responsibility, put all the things I need into it, and then it gets delivered. So that's kind of the heart of it.
Good. So let me continue.
That's pretty good.
Yeah, it's pretty good, Jeffrey. I think he's got it.
Useful.
So let's talk.
Let's applaud how good that was.
Golf clap.
So the next step in this journey,
Do I get a peanut?
this evolution of application development, is serverless computing. How many people have heard of serverless computing at this point? So quite a few of you have. Serverless, in its most strict definition, is an application model or an application platform that has three characteristics. One of them is that it's serverless, and what that really means is not that there's not servers underneath. Of course, there's servers underneath it. But from the application developer's perspective, there are no servers. They simply provide the platform their piece of code, and the platform takes care of executing that code. The platform also takes care of scaling out that code and executing it multiple times concurrently, if necessary, if there's enough requests to run that code. So the developer doesn't have to even worry about scaling rules for their code. The second characteristic is that it is event-driven. And so you're seeing the rise of event-driven programming, something that really was a trend back in the 80s and 90s, really resurfaced now, where code gets executed in response to some trigger. A trigger could be dropping an object in an object storage system, or a tweet showing up in Twitter with a certain hashtag.
Tweeter?
Twitter, or an Tweeter, or an IoT device sending up an alert into the cloud. That could trigger the execution of code. The third characteristic is that it is microbuilt. So instead of the developer having to go pay for resources, compute resources that sit idle, like they might have to if they created a virtual machine and they had a piece of code that was triggered only once a day, they pay for the execution of their code in response to the triggers only, the amount of CPU and typically RAM that the code consumes as it executes. And then once the code's done, they're not paying anymore. So this model is extremely powerful, extremely efficient for a developer, because they just take their code, they focus on their code, define the triggers, deploy the code, and the platform takes care of the rest. We have in Azure three what we consider serverless technologies. Two of them fit that strict definition. One of them is Azure Functions, which is little pieces of code that you can deploy and have it execute in response to various triggers. It's custom pieces of code. The second serverless technology we've got is called Logic Apps. And Logic Apps is integration serverless workflow, where you can define a series of steps with no code at all, connecting to SaaS and PaaS applications that either trigger the workflow, or the workflow can consume inputs or send outputs to. And you define a sequence of steps, much like a program that says, Logic Apps triggers based on this particular event, and then I'm going to go call this other thing to get some input, passing some of the data that came in from that triggered event. Then I'm going to perform some conditional, and if I go down this path, I'm going to do these things. If I go down this other path, I'm going to do those other things. I might even call out to an Azure function if I need a custom piece of code, because Logic Apps is a no-code environment. But once I define the Logic App, like you can see one right here, designed in a visual designer, we just wrote this literally 5 minutes before the session started, and we'll explain what this one does in a second. But now you've got this application. This is actually a robust enterprise application, complete with monitoring and telemetry that's going to come out of the system for every execution. I can deploy it to a particular region of Azure. I can deploy it to multiple regions of Azure. I can check the underlying template. It's an Azure Resource Manager template into source code. But the bottom line is, we didn't have to write any code, and now we only have to pay for this thing when it actually executes. And it can do very sophisticated things with no code. This kind of model, this serverless model where developers just focus on their logic and the platform takes care of the rest, is really the next wave of innovation in cloud computing application models. Cloud native is going to go completely serverless across everything, where we don't have to worry about the operating system, we don't have to worry about auto-scaling, we don't have to worry about patching the runtimes, we don't have to worry about the dependencies other than the ones that maybe our own code, custom code might have. and the platform takes care of absolutely everything else, and we only pay for what we actually use, down to the second. So you can actually, these things get billed at the sub-second level for what you consume. Now, this logic app that we created in literally 5 minutes, you saw Rick said, hashtag Corey and Mark. This logic app, Corey, I'll let you describe the logic app.
Yeah, I can open it up.
Starting with that
So,
first step.
like Mark said, we decided when we got here that we didn't have any mechanism of gathering questions. So we wrote this right here about 5 to 10 minutes before we started. You saw us a little bit anxious because it wasn't quite working at first, but I moved Mark out of the way and I fixed it. And so what you've got here is, it's very, very simple. It's logged into my Twitter account and it's looking for this hashtag. It's looking every single minute. And then what we also added was sentiment, and this is kind of fun because I'm seeing a bunch of these questions already come through, and it's amazing actually. I'm learning how our sentiment analysis works, where if you don't put any, so if you just ask a question, it's about 50%, but one person asks a question and put a smiley face, it goes way up then. So smiley face
put
makes
smiley
sentiment.
faces in.
Yeah, and whoever out there tweeted that we stink, okay, we have traceability.
It was Rick actually.
So,
Oh, you.
And so you can see here, so what I'm doing here is I'm actually running through our, and we'll talk a little bit about AI later, but this is basically a built-in sentiment analysis that is taking the Twitter text that comes through and determining how happy or mad it is. Now, we could add a fork here, right? Very easy for me if I wanted to add a fork here and say if it's happy, do one thing, if it's mad, ignore it completely, whatever you may want to do. But that's a part of that. And then
Corey, we're Microsoft. We embrace
we
the red.
embrace the red and negativity. That's right.
No.
You've had to get used to that.
there's
That's
Corey's
the thing.
phone number, by the way. So if you have any Azure problems, there's.
Oh yeah, there you go. That's whoopsie-daisies. Thanks for calling that out, Mark. So now you'll have live site
recorded,
support.
so if you didn't catch
if you
it,
came to this session, you get live site support. That's for free. So that's that. Anyway, so fine, I don't even care. Whatever, you guys, that's cool. I'm customer focused, Mark. And so this then sends the Twitter text, and it actually, so we'll be getting the questions here. I see you taking a picture down there. I see it. Confiscate all the cameras before we go. And so, we've got, now people are responding. We're seeing quite a few questions come through. This one's got like seven smiley faces. That did go all the way to 1.
All right.
So thank you, whoever gave us Azure T-shirts with new branding, smiley face, smiley face, smiley face. I'm going to read them all.
Yeah.
Anyway, so we will get to the question in a little bit. So keep them coming, and I'll kind of roll back up to the top. But just to show you how, amazingly easy it is to do a serverless solution, event-driven, as Mark talked about, Twitter through, and then this also with the integration and the workflow. It's sort of serverless.
And integrating AI and ML, like we just showed. But this Logic Apps has about close to 200 connectors that allow you to connect to different things. Yeah. Cognitive APIs are just one of them. We could have sent, if somebody tweeted a picture, sent that off for image recognition, or if somebody tweeted a picture with text, we could have done text recognition off the image. If somebody uploaded a video, we could have done something that would have captioned the video for us and sent back that through Logic Apps. All of that is just possible with zero code. And once you deploy it, like you said, like we just saw, we could have thousands of tweets a second, and this thing would just scale up automatically to handle that, and we're paying only for, Corey's only paying for what the execution is. So that's a quick look at serverless and the trends in serverless, I think.
So why don't I try and explain what Mark said?
Okay.
So, was trying to say.
Who invited this guy?
So
Your name isn't on the bill, man.
If you remember writing console applications, right? Begin, end, and then at some point we switched and we had the message pump. Okay, so serverless is like that conversion. Okay, so now the message pump, instead of messages, or you had a message pump, and then you'd write a routine that would handle a particular message. Well, now instead of the messages all coming from the Windows Manager, the messages are coming from the internet. They're coming from all these feeds, from customers, from Twitter, from all these processes. And then your function, there's exactly 3 changes. So that's one, the source of the message pump changes. Number 2 is the code changes. So instead of you having to write all your functions and keep them running in a single function, they can be written by different people in different places, and the life cycle's managed. Now, Azure handles the life cycle of these individual components. And the third is the state. In the past, you'd have your function and you'd have any state you had in the process itself. And now what you do is you just put that process in some durable state so it can be shared amongst those three things. So that's the heart of it. It really is pretty simple model, but it is this conversion from kind of a console.exe, begin, middle, end, to a message pump world.
And I guess the one thing to add, I think, Mark talked a lot about logic apps and functions. The sort of the third component, which I'll talk about since it's in my team and wasn't your idea, Mark, is Event Grid. So one of the services that we just recently launched, it actually was Mark's idea, just to be truthful about that. We launched about a month ago. We launched a service called Event Grid, and what this is it's sort of I think the missing piece when it comes to serverless that you see, especially from our competitors. It treats events as first class. And so what this means is you can effectively write to this platform. It understands events that are coming directly from Azure. So some of the examples Mark mentioned, things dropping into storage, will support things dropping into Cosmos DB, things dropping into SQL, Postgres, et cetera. And so all of those will be hardwired in, including our API calls. But it also supports generic events. Right, and so this is the key difference of what we're approaching with Event Grid is that you can actually use Event Grid and use none of our other serverless platforms. So you can call in with a REST call and the event will go through the system, and you can have someone listening with a REST call at the other end and have someone responding. So you can build your entire own serverless applications without using functions or logic apps with Event Grid. And it's got a bunch of built-in sort of event knowledge. It can do just look at prefixes, just look at postfixes, basically pick out the events that you want, and it's highly reliable. So the event will sit there until someone picks it up for 24 hours. And so it allows you to get really highly reliable event processing in your systems and your applications. So the combination of these three actually offer a pretty powerful set of solutions for different applications.
Now, do you want to take questions on serverless now, or wait for questions?
Well, why don't we go through all the trends, but we probably should go a little faster, make sure we get time for, because we got a lot of questions.
If Jeffrey didn't interrupt, we'd go faster.
So quit the bloviating.
All right, IoT and Edge. You're up.
All right. We talk about intelligent cloud, intelligent edge in Azure. And really, a few years ago, it looked like the cloud was going to be where all of the computing happened. But as time has gone on, we've realized that a lot of computing still has to happen close to where the data and where the devices and where the people and where the interactions with the real world happen. You don't want to have everything being sent up to the cloud. And in some cases, it's just impractical or impossible to. In cases where you're disconnected, like we talked about yesterday, or partially disconnected, or intermittently connected. In cases where the amount of data being generated out close to the real world is just too much to send from a bandwidth perspective up to the cloud, or where you need a close to real-time response to those events that happen out in the real world, where you can't take the latency hit that you would get if you send things up to the cloud, processed it there, and then sent an answer back down. So we're seeing the rise of edge computing, and what we believe edge computing should be is an extension of the cloud, kind of the cloud seeping out towards the real world rather than just a completely different environment out there on the edge. At least when it comes to non-interactive type scenarios. Of course, with interactive edge, you're talking about mobile devices and apps. But what we're talking about is the devices that interact with the real world directly. And one of our core services, of course, targeted to this is our IoT hub, which is the place where you manage your devices and set up your devices and enable them to communicate with the cloud. The next steps that we're taking are to extend the application platform out to the edge through IoT hub, where our first step is you define what's called a module. And a module can just simply be a piece of code or a container, and you define the devices which should run those containers, and IoT Edge then goes and deploys that code and keeps it updated, or it's our IoT hub, for you to be able to push the application model out to the edge. And you see that term container again, common packaging format. In many cases, the containers that you push out to those edge devices are containers and code that you could also run in a cloud. And so this is extending the continuum of where code runs, where you can dev and test it in the cloud, or you can actually decide this thing needs to run in the cloud, or now I want to push this out to the edge to be close to the real world. And where we're going to go on from there is the next step of taking a full rich microservices platform out to the edge. I mentioned Service Fabric when I talked about containers and microservice orchestrators just a minute ago. Service Fabric is a platform that supports containers. It supports rich application models Yesterday, if you came to my session, you saw me scale Service Fabric out to 1 million containers in less than 2 minutes. That same model can work on very constrained devices, that application, that platform. And where this is important is, sure, a little tiny device that can only run a little piece of code, you don't need a lot of sophistication on an app model there, and you can't even afford it. But these devices are getting richer and richer, and there's many scenarios on the edge where you need PC-class devices, and you want them to be highly available and reliable. Imagine the IoT device that is sitting in the operating room, close to the operating table. You want that thing to be highly available and reliable. You also want it to have a rich application model, not a special bespoke thing. You got to program the medical device using a bizarre programming language and application model. You'd like to use containers, the programming language you like, a microservices framework that you like. And so we're pushing Service Fabric out to the edge, and you'll be able to then get a highly available multi-node IoT device for those kinds of scenarios. Even consumer space. You see, if you buy some consumer devices these days to help do home automation, you don't just get one device, one CPU, you get 3. And that's so that they can be highly available, so that if one fails, you don't have to send a technician out to fix it, or you don't have to go take it into a repair shop. It can continue to operate, and you can repair it at your leisure, responding to a notification that it's failed. And so this is the next trend that you're seeing with application models being pushed out to the edge. And then on top of that, tying into what we're going to talk about a little bit, AI and ML. AI and ML is a huge trend in the cloud, but that's also going to be something that's pushed out to the edge, because many decisions have to be driven by machine learning models, and they have to be done in close to real time, and that means you need to push those models out to the edge. So you're going to see ML models pushed out to the edge in containers and executing directly in response to things that happen on the edge with feedback that go into actuators or whatever else to interact with the real world in response. Now with those edge, you're still going to have a lot of data that's going to flow up to the cloud for data analytics, service analytics, business intelligence analytics, archival storage. But a lot of the data is just going to sit on the edge, be aggregated before it goes up, and be processed for machine learning right there on the edge. So that's a kind of a brief look at edge.
I shifted to AI/ML while you were talking.
So, okay, good.
Yeah. I mean, I know you're like anxious to talk about Azure Stack when it comes to the edge.
Well, I was going to just point out, I think you started to tee it up well.
Well, thank you for asking, Corey.
Indeed.
We got to answer some questions.
I'll give you a peanut afterwards.
Keep it going here. Jeff.
So a lot of people think of IoT, certainly I did at the beginning, is IoT is like a Nest device or some Arduino or some Raspberry Pi. In fact, yes, there's lots of edge devices and IoT devices like that. But in fact, we're seeing more and more companies, as they think about it, having much larger and larger ideas of what an IoT device is, including servers with ECC memory and clusters of servers. In fact, a number of people are looking at Azure Stack to be an IoT device. So if you think about an IoT device in general, there's kind of a couple characteristics. So the first is that it's not a general purpose thing to run anything. It has a special purpose, right? It's got an application that it's running. And the second characteristic is that it has fleet management. Okay, that you have lots of these things, and you need to manage the life cycle of a very large number of these things. And again, this is where Azure's IoT capabilities really help. So that's the way to think about it. Don't just think, when you hear IoT, don't just think that Nest device. Think server class machines as well.
Great. So I'll kick off a little bit with the AI/ML story, and maybe I'll talk just about the range, and then you guys can pick up maybe at the top end. So one of the things when it comes to AI and ML is there's really a broad range of capabilities that are available. Starting sort of at the lowest level in the infrastructure side, if you're writing your own models, if you're writing your own calculations, we just announced this week actually is a new set of GPU SKUs. So the P40s, which are available preview today, and these are really geared towards their ND, which the D is short for deep learning. They're geared towards sort of machine learning, deep learning based algorithms and running those at scale. They are InfiniBand connected, so a very, very fast network between them. And we are seeing actually a lot of customers who are deploying sort of massive scale out models in this environment. It's definitely not for the faint at heart. You do have to really sort of dig in deep with machine learning to be able to do that. But we are seeing a lot of interest in that. And with the infrastructure that we continue to deploy, the new sizes conferences. We also announced plans to do P100s here in the coming weeks. We have talked about plans to do Skylake as well. So all our new sizes are really geared towards continuing to push that envelope while still also trying to understand how to give it sort of in the most cost-effective way, how to give you the right SKU makeup. And we'll talk a little bit more about that later. I know there were some questions on that. But that's sort of at the bottom end. And then as you sort of move up the stack, and maybe I'll turn it over to you guys, we look at how do we democratize it as well? How do we make sure that you don't have to be a data analyst to be able to use any aspect of machine learning? In fact, the sentiment analysis that I showed you as part of this Logic app is a good example of you don't need to really understand how it works. You don't need to be spinning up a bunch of GPU SKUs to still be able to take advantage of this in your services, in your environments, running your infrastructure, and so on. And a good example of this is we actually even use it internally to try and detect when hardware is going to fail in our environments, and then actually live migrate customers off of that hardware before it fails. And so this is something that we've started using, a very sort of practical, pragmatic usage of machine learning to be able to predict those failures and reduce your downtime as part of it. And this is something we do on the infrastructure as part of that usage case. So
yeah, and if Corey can write a serverless application leveraging ML, trust me, all of you can. Anyone can.
It's cool, man. Where are your shoes?
Somebody, who asked about Jeffrey's shoes?
There's like multiple questions
first
about
question
Jeffrey's
we're
shoes.
answering.
Yeah, that's right. Joe,
Jeffrey, you want to answer that?
you want to answer that question now, or?
What?
Somebody asked where your shoes are.
Actually,
These
let me
are
ask a different question. How many of these do you have, or is it just like you, these are the only ones you wear all the time?
No, I got
They're just like
about a
wedged
dozen
onto your
pairs.
ears.
These are
Closet full?
Vibram 5 fingers. I got about a dozen.
Yeah.
pairs.
Different colors or just all
No, black.
Clap.
No,
Why are we
I had
clapping
some blue
for this?
ones.
There you go. First question answered.
I'm sure that's what they wanted to hear, Corey.
Yeah, well, there were more questions about that than anything else. Go on,
So
please.
let me talk a little bit about the cognitive APIs, because that's one of the easiest ways you see that we're democratizing access to machine learning and AI. And I mentioned some of the APIs, but the APIs extend across 4 or 5 different categories, and each category has 4 or 5 different APIs. So in the text analysis category, sentiment analysis just is one of those. Another one is language translation, for example. Another one is text to speech, for example. But
image analysis, OCR. Yeah.
But for each of these, this is kind of interesting because a lot of companies come in and they say, hey, what can I do in the cloud that I can't do on-prem? Like, sell me on why the cloud is so great. And one of the things that you can do is this cognitive AI stuff, and you can embed it in just about any application. Chat bots and chat frameworks for interaction with your customers, that's of course one obvious example. Even within your company, having a chat bot that can answer questions for company people, like where's this presentation, things like that. But one of the things that everybody comes in is, oh, I've got this special language that in my domain, my industry, or in my company we use a special language. How do I deal with that? Or I've got certain category of images in my factory floor. How do I do image recognition with that? Because your models are trained on the whole web corpus, and maybe they don't understand the parts that I've got in my factory. The answer is that all of these APIs support custom training. And with as little as 30 images, you can train the image recognition API to understand the images that are unique to whatever your company's doing. Same thing with speech. Same thing with text. You can train it on the vocabulary used in your particular domain. For pharmaceuticals, you can train it on understanding the drugs that your company produces. And both from a speech to text, both from text to speech, as well as analysis of the text and the structure of the text. All of those are trainable with just small data sets, and so you can customize these things for your particular domain.
And there's a really good example of this, and maybe a little bit more. Pharmaceuticals, of course, very exciting. But if there's anyone in pharmaceuticals in the audience, it wasn't an insult. One of the really cool scenarios that we've seen is, or at least that I've seen, is a game actually that was written about sort of a futuristic space flying game. I can't even remember the name actually, but they basically came in and said, look, we're gonna make it a sort of a VR game, and you're gonna speak to the computer and say where you want to go and the planets that you want to go to and so on. But it's all made up. Like almost every word is a made up word, right? And so they said they originally were dealing with the speech understanding using the sentiment using the machine learning capabilities, and it would keep trying to find English words for like these made up planet names. And so to Mark's point, they were able to just retrain it with all these made up words, and it was then able to understand
what is he talking about?
What it was doing.
what are you even talking about?
That all made sense. Who thought that made sense?
It made sense to me.
Thank you.
Oh, it did?
That's a weak clap. Maybe it wasn't any good. Anyway.
So another great example is in the speaker room just yesterday, had one of these PMs come up to me and was like, hey, have you been trying out some of this stuff? I said, no, man, Azure Stack's kept me a little bit busy. He says, it's amazing, because I've been thinking about this stuff, and I'm thinking, oh, I got to sit down, spend a few weeks, get really into this, and become an AI, the level of expertise would be very hard. And he said, no, these guys over here, you got to go see their demo. That they just started using this stuff last week, and they took a bunch of images, put them up in the cloud, and generated a machine learning, a model, and then they pushed that to the edge, and they have these video cameras matching against it. He says, it's so incredibly easy. So these are PMs who get busy doing other stuff, and they just put together this demo so quickly. So, don't think of this stuff as like, oh, you got to have a PhD. Go kick the tires. Apparently, it's pretty easy.
That was a better story than mine.
Corey could do it.
Okay. Let's
move on. Let's move on.
Let's move on. All right, I'll touch on governance, and then you guys can fill in. So I actually think from a trends perspective and from an announcements this week, I actually think this was probably the most announcements this week. I think the set of services that came out are super impressive. Obviously, update management, change management, config management, a pretty big deal to be able to do that hybrid support on-prem cloud, Windows, Linux. But we also announced a bunch of other capabilities too, obviously cost management, and even policy controls. So like a very visual experience around policy controls and being able to decide who can access what, when, and how, and enabling that sort of in groups, right? You can make these initiatives that say, I need to follow these 20 rules, and you can either audit or deny. And so the combination of all these things, being able to do cost management, being able to do policy controls, being able to do update and change, it really offers a much simpler way to run your infrastructure than's ever been possible, right? And I'm pretty excited about it because I think we're finally seeing, in addition to just the agile nature of the cloud, we're finally seeing sort of services that just make everyone's jobs easier to do exactly what they were doing before, but now it's just a simpler view, a simpler experience. And so a lot of these announcements have been pretty impressive and I love them. I think they're some of the best announcements we made this week, actually.
Yeah. Let me add one thing about why I think the cloud is a much better place to do a lot of the things that you've been doing on your infrastructure on-prem, and that is that the cloud is API driven, as you know. Everything that you do in the cloud, you do through an API. At least, unless you're, SSHing into a VM and then installing things manually from there. The idea is to have a declarative API driven infrastructure and application platform. And if you achieve that, if you do things through APIs or do things that are visible through APIs, everything you do, you can enumerate, and you can understand the relationship between all of the objects that you've got that represent the applications, the network rules, and load balancers, and other storage resources. So you get a full topological view of everything that you've got going on in the cloud and its relationships with one another. We take advantage of that API view of the world in our services like Azure Security Center that can enumerate all their objects in your subscriptions, understand the relationships, understands where you're, for example, missing a web application firewall in front of a public IP address or behind a public IP address, and then suggest ways that you can add one, again, driven through APIs, where you can go in the marketplace and deploy one. So from a security perspective, it's very different than the world of on-prem that we've generally lived in, which is every system has been custom created through scripts like PowerShell. Nobody understands how to manage them anymore. Nobody understands how things are connected anymore.
What?
Where in the cloud, you get into a much cleaner, more consistent view of everything that's going on, and that lets you have a more secure, more reliable, more highly available environment.
Yeah, if you thought you saw an increase in the announcements this year over last year, that's true. And I expect next year to be even more so. And the phenomena going on here is that I have this joke around, nobody cares about your first million lines of code. And the observation there is that if you're going to do something substantial, there's a whole lot of infrastructure that needs to you need to put in place. And often you don't see any results from that. But at some point you hit this critical mass of infrastructure, and then all of a sudden, once you have that first million lines of code laid right, then you can write 500 lines of code to tie it all together and have amazing things. And that's why one of my jokes is like, never leave a project when you have 990,000 lines of code written, right? Because then you're gone, and the next guy comes in, writes 500 lines of code, and everyone's like, oh, thank heavens we hired you. Paying that idiot for years and nothing ever happened. You're a genius. Well, really, Azure has really laid those foundations, got the core architecture right. And now we have a set of services, and they just keep building and building and building. And now people are able to come in and write, relatively, still big, but relatively small amounts of code to tie these together to do amazing things in rock-solid ways. And it's just going to happen, and people are going to build on those and those. So it is going to accelerate. And again, unlike on-premises, these things are going to be delivered in a continuous way. Like, look, we made some fantastic innovation in Windows Server. Each release, we continue to do that. And often, it's a very hard problem. Like, you don't have access to it because your companies haven't figured out how to ingest that new capability and deploy it throughout your environment. In the cloud, it's available as soon as we make it available. So,
yeah,
huge benefit.
All right, we want to go to the last trend here, and then we'll start taking questions. So keep sending questions. We will go back and go through them. So don't be concerned that we've missed them or lost them. So do you want to kick this one off? You're
Sure.
super excited, I can tell. Yes, geoscale.
How many of you work at a company that's multinational, works across different countries? So almost all of you. So, and you've got applications that are going to deliver to your customers regardless of where they are in the world. And so that's one of the reasons the cloud looks attractive, I think, to many of us, is that the Azure's in many countries around the world. Now, one of the trends that I think we're going to start seeing here is development models for geoscale applications. Ones where it's not you deploying an application instance in this place and another application instance in this place, but rather you're deploying an application across the world. And that application then is serving customers wherever the closest they are. The data is being replicated, and the application has a consistent view of the data regardless of where the compute happens to be running. The first steps in this trend are, I think, exhibited with services that we've got like Cosmos Database. How many people have heard of Cosmos DB? Cosmos DB is a NoSQL database. It's a multi-protocol database or polyglot database that supports 4 different APIs on top of it. And that by itself is kind of unique and differentiated. It's got some other unique and differentiated characteristics that also represent trends in the cloud, like SLAs across the 4 dimensions of SLA, of latency, throughput, availability, and consistency. But in the context of geoscale applications, it represents this trend for you being able to take a data service and specify through a visual designer that has a map of the world. Of course, programmatically, you can do it as well to say, this database should be replicated across all of these regions. And once you set that in place, then compute that you've got executing any of those regions has very low latency access to that data, but yet that data is a consistent global view of the data. The next step in this is an application model where you can define the compute and say, this compute should be running everywhere around the world, and this data should be replicated to that compute. And it should support DR and failover. It should support high availability. It should support shifting the data close to wherever the users happen to be. As maybe the day crosses over the world, the data is over in Asia, then it moves to Europe, then it moves to the US, and it's the hot part of the data is close to where the customers are. This is kind of uncharted space, but this is where we're going, is the ability for you to define structurally these applications, to be able to test them, debug them, and deploy them at geoscale with the consistent views of data and DR capability. So if this region fails, then a failover automatically happens. I understand exactly the characteristics of how the app is going to work with respect to any data loss that might occur because I didn't synchronously replicate everything. That tools that we're going to be giving to developers to make it easy to write those kind of applications you're going to see those evolve quickly over the next few years. And this is something that today a lot of companies that we work with, Corey was just mentioning Jet.com, is one of those companies that works across the world, across regions, and they've built this highly available infrastructure, but they had to do a lot of heavy lifting and a lot of custom architecture to do that. We're going to take those patterns and build them into the platform itself. You want to?
Yeah, I mean, I think Cosmos DB is the right example of sort of how this is moving forward. I think it's a service that's built intending to support this. And a good example of this is that it's not just doing replication, but the ability to choose your consistency model, even based on call, right? So like the good example for like a retail company would be shopping carts maybe can be eventually consistent. They need to be really fast locally. If you end up being a little bit behind, if you fly from the East Coast to the West Coast, it's probably okay, right? You're not going to get super nervous about that. But when you make an order, that needs to be strictly consistent, right? And so you're willing to take a little bit maybe of a latency delay to make sure that the order's locked and loaded on 2 locations, and you've got that story across the country or the world. And so I think that ability to have that picking and choosing is sort of a good example of the direction that Mark's talking about, where apps are going to be more expected actually to just always be active, always on, globally scaled. But right now it's really hard. I mean, that's kind of a simple example, but writing all of your apps, all your compute, all your data in such a way that you can do that, it's super, super hard. I think this is something that you'll see a lot of investment from us in trying to make it easy, trying to give you the tools and the services and the products that can do it and allow you to make some of these trade-offs in a little bit of an easier way than a ton of code that needs to be written specifically for this.
Yeah, you know, our industry always has been, is, and always will be about leverage. Okay? The people who can figure out how to leverage others most are the ones that benefit the most. I think everybody's eyes really opened up to the reality of that by that small messaging company that Facebook bought, right? And I think the numbers were that they had 50 employees and they were running in a number of different regions because they were using a public cloud, and they sold the company to Facebook for $15 billion. 50 employees, $15 billion. And how were they able to do that? And the answer was they were leveraging the public cloud. And so I think that made a lot of us step back and say, whoa, this is incredible. We should all be doing
startups.
We should all be doing startups.
That's what you're saying.
But the interesting thing about this was twofold. One was, it was a relatively simple application, and it worked in a relatively small set of places, or it worked in wide places, but not very wide. Now, I actually don't like this term geoscale. It might be nice, but I like the term planetary scale, because Azure really is planetary scale. And so the thing we're pointing out here, no, it really is. Have you seen that region map?
Yeah,
it's incredible.
Right.
42 regions, and then those APIs and services, Azure Stack is going to make them available through service providers, even more places. You'll be able to run your applications really across the planet. I'm really quite serious about that. But the level of capabilities, Cosmos DB, boy, that enables far more sophisticated applications than these guys were doing with that startup that they did, that messaging company, right? And the ability to have low latency access to the entire planet really is incredible leverage like we've never seen before. I truly anticipate that there will be people, hopefully some of the people in this room, that are going to be able to figure out how to take advantage of this leverage to produce unparalleled value and to benefit thereby. So really, figure out how to take advantage of leverage.
Okay. All right. Let's actually, why don't we, since we've got a set of questions, why don't we just, are you going to, you want to do?
Actually, before we start, any trends that you think that we didn't cover here? Anybody got any trends that you'd like to see us talk about? Yeah. So
repeat the question.
Yeah. So the question is, how do we deal with embedded devices that are limited in functionality to, you know, how does it relate to what we've talked about? So I think in that case, if the device is really limited, like I'd mentioned before, a device that might be only capable of, you know, might only have tens of megabytes of RAM on it, so it's really tiny, kind of super embedded device, maybe it's implanted or something. How do we deal with that? Well, for one, where you see us going with IoT device security, especially in that kind of scenario, you need to have a secure bootstrap of that device, so to ensure that only the code that is authorized to run on that device is running on that device. So that's one of the fundamentals. But then as far as application models out to the device, that's where you'd say, if that device is really constrained, maybe it can't even run a container, maybe a container infrastructure is too much for it, so I'm going to define just a little module of code that gets deployed to that. Again, it's going to be governed through IoT Hub, through CI/CD with source control, test integration that automatically ensures some quality before I actually push that code out. And IoT Hub would then give me the ability to update that code if there was a problem, get telemetry back from that device to understand how it's working. So while you're more constrained, still the fundamentals are still going to be there to support that kind of model. And I'm not sure if I answered exactly what you were talking about. Yeah. So the problem is that you're collecting, and you need to respond to it in a short period of time? Yeah, so the question, I think, was more about this device is constrained, but still needs to have some interactivity, and it can't go back to the cloud. So maybe an image, it's capturing images and needs to respond to that. Well, Corey talked about that, or I think Jeffrey talked about that yesterday, these PMs that took a machine learning model that they'd trained in the cloud and pushed it out to the edge. So modules will support ML algorithms being pushed out to the edge. That's what I was talking about earlier. So it could be image recognition. That's kind of one of the obvious ones. I'm going to push that out to the edge. Cameras, smart cameras are going to be a great example of this, where image recognition is going to be pushed out to the edge, and you'll have image detection, shape detection happening right out on the device itself, and that device could be a constrained device. These models, a lot of these models are actually fairly small and can be running on fairly low power CPUs.
Shall we do some questions?
Sure.
Yeah. So, I can you want me to just kick them off here? So, where'd that go here? Okay. So one, I guess, let me just jump in. So the first question we got was about spot pricing and asking whether we're going to have that on Azure Compute. And so I can address that. So we actually just launched GA on Monday, low priority batch. And so what we've done here is it's effectively the same as in a lot of ways the same as spot pricing. Just to give you a little bit of background on sort of what's happening here behind the scenes. You know, when we buy out our capacity and deploy customers on our infrastructure or deploy other services on our infrastructure, we have a lot of buffer space. We have buffer space protecting against failures. So if a rack goes down, we want to make sure we have enough to basically recover everyone onto another rack. We also have a buffer space for people to grow, right? As it turns out, an agile environment is very hard for us to manage because everyone's growing at random times, and so we have a good amount of buffer space. So with low priority, we actually are reselling that space. We're reselling that to you at a low price. And so the idea here is that we give a big discount, but then we reserve the right to throw you out when we need to. And this is sort of what spot pricing is as well. The big difference that what we've done is we don't have a variable pricing model. One of the things that when we've talked with customers, they'd prefer a consistent pricing model versus sort of a market approach where you don't quite know what you're going to end up paying for your job.
Yeah, how many people have used Amazon spot pricing? Raise your hands. And so those of you that have used it, have you seen the spot price actually go above the on-demand price before? Yeah. So that's one of the complaints that we've heard.
Exactly. Yeah. So, and then the combination of that with Azure Batch allows you to control when your job gets done. So you can go in and say with Azure Batch, look, I only want to be evicted 3 times. I need to finish by Friday. So it allows you to try and get the lowest price possible. So that did GA this week, and then that schedule, you didn't know that was possible, did you?
Oh, that's pretty cool.
Yeah, it's very cool. So we actually do some good stuff.
Yeah, I should get a pen. I write that down.
You should write that one down. That's a big day. Jeffrey's learned something. Yeah. Okay, yeah. So it is a very, very cool cool combination of services, and that did go GA this week. So you're free to use that now.
Wow.
This one's come up 3 times.
Jeffrey's shoes.
Jeffrey's shoes, but besides that, actually work related.
Who's got the best shoes?
No. Is any news
Chris
on
Jackson.
Gen 2 VMs?
That came up how many times?
Came up 3 times.
Did you tweet that in like 3 times? Gen 2
I do have
VMs.
to ask that.
Oh. This is an ongoing joke between Jeffrey and me, because Jeffrey asks for this every time I see him, and I say no. I guess actually, as it turns out, we just launched the confidential computing. That is built on Gen 2 VMs. So there's sort of 2 parts of Gen 2, our transition to Gen 2 VMs in Azure. And we saw this question on another one, which is, are we just using stock Hyper-V? And the answer is yes. So we are just using stock Hyper-V. Right now it's on 2012 R2, but I'm sorry, it's halfway.
We already started transitioning.
Yeah, we're halfway through. Yeah, that's right. Thank you. Yeah. So anyway, so the Gen 2 question. A lot of our newest sizes are going to be dependent on Gen 2, right? We just don't have a choice, and so confidential computing is a good example. The M series as well is sort of using Gen 2 capabilities as part of it. One of the challenges we have is that it is actually sort of a breaking change in format, right? Going from the existing format to the new Gen 2 format, and so to enable that broadly across all of our infrastructure, there's a bunch of additional support tooling that we need to build. Things like conversion, right? Helping people to understand, okay, right, I'm running in the additional current VMs, I want to convert to Gen 2, right, and thinking through sort of how all those experiences work. So it's absolutely in our list, and like I said, some of our newest sizes will require it and only support Gen 2. The hardest part is going to be our existing sizes where we kind of need to support both. And then also, there's a lot of customers in the world that don't know anything about Gen 1 or Gen 2, and part of the value of the cloud is that we don't really want them to have to know about that. And so there's also that challenge of we kind of don't want to expose it, but we are going to be able to enable that also because we would like the transition from on-prem to be a lot easier, and obviously Gen 2 is the default Hyper-V on-prem.
It's worth pointing out that Gen 2 is not all upside. There are some downsides. You lose the parallel port.
Right.
So if any of you are dependent upon that, Centronics connectors, they're gone.
It's great to have you on stage.
Nice. Question, I don't know if we're going to do this one. This one could be for Mark. How about this one? When is quantum computing coming to Azure?
When is quantum computing coming to Azure?
What's the ETA?
I want to know the answer to that.
Are you allowed to talk about roadmap stuff?
Well, it's coming in a simulated way, as we saw, just in a few months. So you'll be able to play with the Visual Studio in the simulator.
Yeah, the simulator.
But from real quantum computing, I mean, this is one of those things where you ask 5 people that are familiar with the space, and you get 5 different answers about when quantum computing is really going to become mainstream and practical. Right now, the challenges with quantum computing is that sustainable for enough time for you to be able to actually do some computation, the number of qubits is very low. It's like 3 to 5 kind of qubits, and for a lot of these computations, you need over 100 qubits to be stable for long periods of time. The other problem with it, and I don't know how much you heard of.
It's cold.
Yeah, well, you got to run it at 4 degrees Kelvin, so that's really cold, and you need to keep a lot of interference away from it. But even still, it's kind of the algorithms behave non-deterministically, so you've got to have a lot of error correction, and you have to run the algorithm typically multiple times to actually get a solid view of what the answer will be. So there's a lot of these challenges that have yet to be fully solved, and they need to be solved at least to make it mainstream. At least, I think you're going to see the first kind of sustainable in a lab environment quantum computing in the next few years to actually be mainstreaming where companies are able to go buy quantum computers themselves off the shelf. That's probably 5 to 10 years kind of time range, I think. More towards the 10.
The big news this week.
Are you going to say Azure Stack supports it today?
But again, that's just my consolidated digestion of what all the people that I talk to that are working in this field kind of tell me. Because some people are very aggressive to say, oh no, this is going to be 3 years away, and other people are like, no, this is 15 years away. So this is kind of in the middle.
It's always hard to predict the progress on revolutionary things like this. Quantum computing as a concept has been around for a long time, but most people felt that it was, fantasy, science fiction, things would never happen. But we had a number of people in Microsoft that had started to commit and invest in this a long time ago, over 10 years ago. Craig Mundy, in fact, he was backstage. This was his child. He did this when a bunch of us were looking like, Craig, what are you talking about? And through a lot of investment, a lot of hard work over the last 10 years, we're now to the point where we are, now most people are looking at us and saying, it will be a reality. Now the timing, people disagree, but it will be a reality, and that's the thing. That's the thing I'm very proud of Microsoft, is in really kind of taking the transforming possibilities into reality. So that was the big news.
Oh, by the way, I misspoke. It's not non-deterministic, it's probabilistic. These algorithms are probabilistic. I mean, there's
and
like
being
80% chance that this is the right answer.
Being very pragmatic, I was watching the demo and immediately thinking to myself, who's going to run that live site when things go wrong with like the suit inside the 1 degree Kelvin?
Well, that's
I'm not doing that.
That's your story. Well, you live in New York, so you're used to the
I
cold.
can do it there. That's right.
You can do it. You can do it.
What do you got?
Okay, how about if you were comic book hero superheroes, what would each of your names be, and what would your superpower be? Gonna go with Mark first because he looks like he's completely stunned right now.
Jeffrey, you go first.
I think we should do each other. Mark's superpower is his ego can crush anyone.
Wow.
Just kidding. He's not.
I'm crushing
He doesn't
you
have
first.
an ego at all. Yeah, you're gonna crush me physically later. Anyway, Jeffrey, please. What is yours?
I have no idea.
Come on.
I have no idea.
Why don't we ask the audience to?
Yeah,
say what-
fine.
Yeah, tweet some suggestions.
Please, some suggestions.
Yeah, hashtag Mark Russinovich is.
Let's maybe not do that.
Let's
move on.
We'll go back to the ones here. Okay, here's one. How about what
Great,
OS
by the way,
breakdown?
it was a great question that we totally failed at. So,
What OS breakdown do you see in Azure? And which are the most popular services? I know Corey's going to answer IaaS and Compute, but I'm interested to see what the CTO has to say.
Yeah, we'll let
for
Mark
most
take that
popular
one since
services.
I've obviously got a strong.
The most popular service? Well, as in the
Actually,
most liked or the most used? That's kind of.
Ooh.
Well, you should do that. Let's focus on customers, which actually is not. It's actually not infrastructure, right? The most customer used.
Yeah, it's app service.
Is app service.
Yeah. App service has the most customers. Web apps.
Then
predominantly
VMs
driving.
is of course second. Just to be clear. But yeah, and then
the first half of that question was, what is the OS breakdown that we're seeing? That
what
you
is
can
the
share?
latest numbers?
Well,
33, more than 33%.
more than 33%, more than 1 in 3 VMs deployed are Linux VMs, and more than 50% of the VMs being
new
deployed
VMs.
right now are Linux VMs.
Right, and that's all infrastructure, right? And then if you take into some of the other services that now are also running on Linux as well,
like HD
like
Insight.
HD Insight, some of the Postgres services, and so on. So yeah, it's,
By the way, there are two factors behind that. So first is that one, people are getting their head around the concept that it's really true that Microsoft is a cross-platform company and that we will support Linux VMs this much and as more, if not more so than Windows VMs. And the second is that we are getting better at this. If any of you had tried a Linux VM, a few years ago and said, hey, this characteristic isn't as good as other platforms, try it again. We have gotten very, very good. In fact, great news. I mean, we're working very closely with the Linux community. One of my teams is working with, just announced work with Ubuntu, where there is a custom version of the Ubuntu kernel optimized to run in Azure. Okay, so we have worked very heavily to make sure that Linux runs fantastic in Azure.
Yeah, and we're part of the Linux Foundation. We're
Linux
doing
Foundation.
that a couple months ago.
yep, CNCF.
CNCF, Cloud
Foundation.
Compute Foundation.
Yeah, we're also part of the .NET Foundation.
Yeah, and actually, so the way that we view OS. What? And
No,
is there
I'm just
a
saying it's
PowerShell
an
Foundation?
obvious one that we're a part of the .NET.
Yeah.
No, there's not a PowerShell Foundation. There's Jeffrey.
Yeah, exactly.
Part of the Jeffrey
I am
Foundation.
a foundation. Anyway, we got some more questions. Well, first of all, we have a comment here. Corey is Captain America, obviously. So that came through.
Is that yours?
Yeah, but then the next part of the comment was, Ori is out of shape double, which is sentiment analysis 0.5. That's not true.
Yeah. The before picture of Captain America.
Negative. Wait, we had one here that I thought was really good. Let's see here. Will Cosmos DB or any other service be aware of compliance data or to respect legislation?
Oh, as far as, I think, geo-sovereignty, where the data can go?
Yeah, I guess, that's probably good. And then obviously the new European laws as well, right?
Yeah. Well, so for one thing, the database will only replicate to the regions that you specify. So I'm not sure I understand the question, because our services are certified, get certifications, and those certifications apply regardless of what region the service is running in. I think maybe the question is from the regulations that govern where specific data can reside that might be in a database. So today, a database that you specify for replication, any of the data in that database will be replicated to all of those locations you specify. I think maybe what the question is asking is, in the future, can I tag certain parts of data, certain data in a database and say this data has to reside within this country and can't leave it, but the rest of the data can? The answer is we haven't gotten down to that granularity in terms of replication, but if we see enough customer demand, that will be a feature that for sure we'll add.
Oh, I think you downplayed.
And I guess, how many people would like to see that feature? Just out of, so 3, that's
4.
it? No,
4
sorry.
claps.
Sorry.
That was it.
Riveting.
I think you downplayed the certifications that Azure has. You guys have done a fantastic job.
downplay it.
You should really highlight it.
Jeffrey,
Right.
I thought he downplayed it too, to be
Yeah.
honest.
All right, did I down?
Did he?
All right, here I go. You got me started.
ISO 27001.
Yeah.
No.
So our number of certifications we have, our services, the count is 67 now. So I don't even know them all. And there's international standards, government standards, industry vertical standards, and so we've got as far as the number of certifications, the highest number of any major public cloud. We also have the broadest coverage across our core services. Yeah. So if you take a look at any public cloud, they've got a list of certifications. That full list of 67 is the total certifications we've got. Basically, there's a set of services that have achieved all those 67, and those are the core services like the virtual machine service, for example, but not all of the Azure services like Event Grid, of course, hasn't achieved certifications because it's in preview. So, and there's even some services that are in commercial GA that will only have a core set of services, certifications. Specifically, ISO, FedRAMP, and SOC are the ones that we consider the core certifications. In terms of those core 3, we've got the broadest coverage of services as well of any public cloud. So this is, again, going towards one of the value propositions I think we've got as Microsoft is understanding enterprise needs, understanding how to develop enterprise software, and part of that is how do we develop compliant software and have a machine to get these certifications.
Yeah, when you think about certifications, there's really 2 flavors of this. First is, for my workload, I require these specific certifications. So lots of great details, blah, 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 great. The other is certifications act as a proxy for, are these people I can trust? And so there, just look at the mass of it. You know, Azure is a cloud you can trust your computing on.
This one has a rather low sentiment value, 0.02.
Whoa.
When will we be able to kill on-prem Active Directory and run our identities 100% in the cloud?
The word kill really.
The kill, I think, really
Although
kind of knocked that down.
I view as a positive sentiment because that's saying when can we move to the cloud?
Yeah, we should really go train it to better understand cloud positivity.
Jeffrey, get on that.
Jeffrey, do you want to get that one?
Yeah, no, I think I think you know, we're going to have a hybrid cloud for a long time, and for a long time, I don't know that it's going to ever
That's a
be
great
gone.
answer.
Wow,
Really
deep
insights from
super valuable.
Jeffrey, yeah.
That's how you get to be technical fellow at Microsoft. Yes.
Okay, with Corey's expertise in building serverless applications in 5 minutes before we started, if you go ahead and build one of these applications, what guarantee do you have that the services that you're using aren't going to disappear with the speed of evolution that we have inside the cloud?
Oh, that's a great question.
I extended upon it
Oh,
from the 140
as in like
characters.
we would like deprecate a service?
Yeah, if you deprecate a
shut it
service,
off?
it's going to be
yeah.
around.
So
Mark's got it.
going back to the fact that we're in enterprise cloud.
If you talk about VM role, I'm walking.
Yeah, we will not. Well, let's talk about cloud services.
Yeah.
Yeah, so cloud services is like what we consider PaaS v1 in Azure. It was the v1 of our approach to microservices and scale-out architecture.
Who actually is anyone still running cloud service in the audience? Yes.
Did you ask that question, by the way?
No.
Okay. So the answer is that we will never, as long as customers are using it, we will never shut something off. That's part of an enterprise-grade promise to our customers. So cloud services, you know, as people say, oh, cloud services and the Azure service model, what's the timeline for that? They're clearly deprecated in the sense that we're not evolving them any further. We're not adding new features to them. All that feature work's happening over on Azure Resource Manager and VM scale sets and virtual machines and microservices and containers. But we will not shut that service off. And what we're doing over time is actually making it easier for people to migrate off of that onto something modern.
Yeah. I mean, that last point is kind of the key point, and cloud service is a good example where, you know, I think even as Mark mentioned, right, we're not going to shut something off, but even when we do decide, hey, we're going to start reducing feature focus on services, we do spend a lot of time thinking through how we're going to help customers migrate. And in fact, for many cloud service customers, we have helped migrate. We have got them able to move over. But some that are still there, we're not kicking them off, as sort of Mark mentioned. And we're continually trying to think through additional ways to help migration to some of the newer stuff work. So it's definitely something that we think about a lot, but we definitely take seriously as well. What?
Question for Jeffrey.
Oh, God.
What's that?
Where does this leave the future of IT pros? Will we all become devs or help desk?
That's for Jeffrey.
Oh, great. Yeah, so I do believe that in the future, the role of IT pros definitely changes, right? But I think I'm very positive and optimistic about this, right? So I think, and in fact, in my talk this week, digital transformation, I provided a roadmap for people, processes, and platforms. So if you haven't seen that, go back and read that. It's very optimistic about the role of IT pros. And in fact, Microsoft is the company. Here's the thing, I talk to a lot of customers and I hear, okay, great, so I understand my world, right? The world of the last 20 years. And I now understand this world of the cloud. But how do I get from here to there? Right? Do I just have to become as smart as Mark Russinovich? Is that the bar? And the answer is no. You know, Microsoft is going to work with you to provide you step-by-step guidance for how to get from here to there. My kids, when they were little, loved the joke, how do you eat an elephant? And the answer is one bite at a time. And so we've got these step-by-step processes to get you from here to the cloud. And in terms of the roles and responsibilities for IT pros, we define a new set of roles and responsibilities. There is the Azure admin. There is the Azure solutions architect, the cloud architect. There's the Azure Stack operator, and then there's DevOps engineer. Okay, now DevOps engineer is an engineering world, it's an engineering team, but there are two types of engineers, right? It's all based in code, but some of those coders will be writing C# and Node.js and serverless functions, and other of those engineers will be writing ARM templates, documents. They'll be writing desired state configuration, documents, and PowerShell scripts. But it's code, and it's engineering. All this code goes into GitHub. There's tracking and traceability for all the change management, and you do things in small batches. But those are the four roles going forward, right? Architect, cloud admin, Azure admin, Azure Stack operator, and DevOps engineer. And if you go up to our website, we have paths for each one of those things. We have learning paths, we have training, we have certification. We have certification for all of them except for the DevOps engineer. That's something we continue to work on, but there is step-by-step things. So I'm very optimistic about the world of IT pros. And by the way, the folks who have made it through that knothole, you know, I have this concept of there's this world and there's that world, and often there's a knothole in between. Like, it's hard to see that other world until you get through the knothole, and then you're just like, oh, I get it. The IT pros that have gotten through that knothole and are living on the other side of that new world are having a blast. And by the way, many of them are making a lot more money and having a lot more rewarding careers. So, because what's so fun about this new world is, you know, it's just so fun to talk to a customer and then very quickly turn that into a feature to satisfy that customer. And when you make that connection and see that customer happy, man, it's just like that first hit on a crack pipe. You want more.
Well, dear Lord. Oh. Okay, well.
I don't know what that sentiment's going to come out as right now.
And wow. I'm optimistic that when Jeffrey comes down from whatever he's on, he'll find his shoes. So with that, wow.
Yeah.
Not recommending that.
Can we cut at that point, like 5 minutes early? So we're done. I think the time's over. And
I think PR is going to shut us off.
Yeah,
right
PR
now.
is going to, well, shut Jeffrey down for sure. They've got their sights on him now. Thank you guys so much. We actually are at time. I appreciate you guys coming. Great questions, great energy. Love it. Hope you're enjoying Ignite.
And if you like this format of the session, please put so in the evals, because we'll use that to decide whether we do this again. So hopefully you found it useful. Thanks.
Yeah, please. Thank you. Bye-bye.